Hello dear students. So in the unit metallurgy, we have learnt that a metal can be extracted from its ore, and that comprises of three stages. First one is the concentration of the ore, and the second one is the extraction of the crude metal, and the third one is the refining of the crude metal. Now in this session we are about to discuss the third stage, that is refining of the metal, or I can say refining process. See, the metal that is obtained after the extraction from its ore comprises of some impurities, say such as unchanged ore may be present in that. Other metals may also be present, which is produced by the simultaneous reactions, they say. Some non-metals like silicon, carbon, phosphorus may also be present, and sometimes some residual slag and flux may also be present. So these impurities are present, and therefore it is our responsibility to remove these impurities to get 100% pure metal. So as a result of that, purification is necessary, they say. Now we have different refining processes are available. Now depending upon the nature of the metal and the nature of the impurities, different refining processes are available. What are they? Let us see one by one. First one is distillation. Second one is liquefaction, electrolytic refining, zone refining, Mond's process, and Van Orkel's method. So these are the various refining processes available. And let me repeat again. So depending upon the nature of the metal and the nature of the impurities, different refining processes are available, and we have to apply different techniques for under different conditions. First, let us see distillation. See, this refining technique is used for metals which are easily volatile and low boiling. For example, zinc, mercury, cadmium, etc. can be refined by this method. So these metals have relatively low melting point, and they are easily volatile. Volatile, we have learnt already that a substance which undergo easily evaporatable substances are called as volatile. And also we know distillation comprises of two processes, that is boiling and condensation. Boiling, we know, is a change of state from liquid to gas, and condensation is the reverse, that is a gas is again condensed into liquid. Now this refining process takes place in a retort. The diagram is shown here. In that retort, impure metal is taken. It is heated first. When we heat, what happens? Now, as we have said, it is an easily volatile substance. That vapors are vapors start coming out from the metal, and it passes into the other chamber. There, in the next end, cold water is poured upon that. As a result of passing of cold water, what happens? That vapor will get condensed now. So condensation takes place. Whereas the impurities which are present along with that metal will be left behind in the retort itself. Whereas the low boiling substance, or I can say the metal which we are refining, comes to the other compartment, leaving behind the impurities in the retort. So in this way, distillation can be explained. The next process is called as liquefaction. So in this refining technique, we can refine some metals like, say, bismuth, tin, lead, mercury, etc. Now this liquefaction is used to remove impurities with high melting point from metals with relatively low melting point. So one thing you have to remember here, the impurities present in the metal, they have very high melting point, whereas the metal itself has a very low melting point. Here, this refining process takes place in a reverberatory furnace assembly. That is a sloping hearth. We got a diagram there. Sloping hearth, that is slope. The impure metal is placed on the sloping hearth of a reverberatory furnace, and it is heated. You could see that heating source there. Once when you do so, what happens now? Since the metal has a very low melting point, it melts first. So it melts and flows down. Now what will happen to the impurities present in the metal? That will be present in the top itself. So since that impurities present in the metals, they have a very high melting point, that will not melt first. So only the metal which has a very low melting point will melt first, and therefore the metal melts and flows down, leaving behind the impurities on the hearth itself. So this technique or this refining technique can be used for refining metals such as bismuth, tin, lead, mercury, etc. Now the next refining technique is called as electrorefining, or you can say electrolytic refining. Among all the refining methods available, this electrolytic refining is very important. Why? It is because many metals such as say copper, silver, gold, lead, nickel, etc., or zinc even, are purified by this method. And hence this method is considered to be the important among all the refining techniques. Now in this electrolytic refining, we need to remember three terms. One is called as anode, other one is called as cathode, and the third one will be electrolyte. Now the metal to be purified is taken as the anode. Then that particular metal's pure sheet or pure metal is taken as the cathode, and aqueous solution of the salt or a complex is taken as the electrolyte. We will consider an example, then you might understand a bit better. So let me repeat. Anode is the impure metal, cathode is a pure metal in the form of a sheet, and electrolyte is that particular metal salt solution, aqueous solution is taken as the electrolyte. Now when you pass current, that metal, it dissolves from the anode, it passes into the solution. So on passing the current, what happens? The metal dissolves from the anode, it passes into the solution. At the same time, equivalent amount of metal ions from the solution is deposited on the cathode. Okay, so here in that impure metal which we have taken in the form of anode, as I said, that impurities are present. Here the soluble impurities present will pass into the solution, or I can say it dissolves into the solution, whereas the insoluble impurities, usually less electropositive metals, they say, that insoluble impurities settle down at the bottom in the form of a mud, which we call it as anode mud or anodic mud. Seringla, when you pass current, that metal dissolves from the anode, it passes into the solution. At the same time, equivalent amount of metal ions from the solution is deposited on the cathode. So again, soluble impurities pass into the solution or dissolve in the electrolytic solution, whereas insoluble impurities settle down as anode mud. In short, and the anode irukkudiya metal. So metal is transferred from the anode to the cathode. Anode irukkudiya metal cathode ku pogudhu through electrolytic solution. So metal is transferred from anode to cathode through solution. Let us elaborate this by considering one example of silver can be given as an example here. Let us consider the electrolytic refining of silver. So since we purify or since we refine silver, here cathode anode electrolyte, pure silver is taken as the cathode in the form of a sheet. Impure silver is taken in the form of a rod as the anode, and a silver nitrate solution or aqueous silver nitrate solution is acidified with small amount of say dilute nitric acid, or I can say acidified aqueous silver nitrate solution is taken as the electrolyte. Now this entire thing takes place in an electrolytic vessel, which you can see in the diagram. So here what happens when you pass electric current? So at anode, oxidation process takes place. Likewise, at the cathode, reduction process takes place. Now what is oxidation and what is reduction, we know according to electronic concept. According to electronic concept, loss of electron is considered to be oxidation. Likewise, gain of electron is considered to be reduction. You can easily remember by remembering one accord, that is a oil rig. So oxidation is loss of electron, whereas reduction is gain of electron. So at anode what happens? There is a loss of electron from silver. So silver becomes Ag plus when one electron is lost here. And at anode, gain of electron takes place. So there silver gets deposited. So in this way, we can explain the process of electrolytic refining by considering silver as the example. Our next refining technique is the zone refining. We can also call this as a fractional crystallization. In the zone refining, say elements such as silicon, germanium, gallium. Now these elements are used as semiconductors. So these elements are refined or purified by this technique called zone refining. இங்கே நம்ம என்ன செய்கிறோம்னா we have to heat that impure metal. That impure metal, when it is melted and allowed to solidify, என்ன ஆகும்? Impurities will prefer to be in the molten region. அதாவது we have to take that particular metal to be purified in the form of a rod. அந்த rod formல எடுக்கிறோம். There we have to fix one heater which is usually movable in nature. So a movable heater or a mobile induction heater is fitted around the rod of that impure metal. இது ஃபஸ்ட்டுங்க. அதாவது நம்ம எந்த ஒரு மெட்டலை ஜோன் ரிஃபைனிங் டெக்னிக்கில் பியூரிஃபை பண்ணுறோமோ அதை ஒரு ராட் ஷேப்பில் எடுத்துக்கிறோம். அதில் வந்து ஒரு ஹீட்டரை அட்டாச் பண்ணிக்கிறோம். இங்கே என்ன பிரின்சிபல் சொல்கிறாங்க அப்படின்னா, the impurities present in that particular metal are more soluble in the molten state than in the solid state of the metal. This is the most important point you have to remember. That is, the impurities present in that particular metal which we are refining or which we are purifying are more soluble in the molten state than in the solid state of the metal. Then another one point you have to consider here, that is this particular zone refining process is carried out in an inert gas atmosphere னு சொல்கிறாங்க. எதுக்காக வந்து நம்ம inert gas atmosphere இங்கே ஃபாலோ பண்ணணும்? To prevent the oxidation of the metal under consideration. சரிங்களா? So for that purpose we have to maintain an inert gas atmosphere. So a movable heater or a mobile induction heater is fitted around the rod of the impure metal. Then we have to slowly move the heater across the rod. So the heater is slowly moved across the rod. Once when we do so, what happens? The metal melts. எந்த இடத்துல இந்த metal melt ஆகும்னா at the point of heating. So the circular heater வந்து எந்த இடத்துல உங்களுக்கு வந்து கான்டாக்டில் இருக்கோ in that particular place at the point of heating, the metal will melt. So the metal melts at the point of heating, and as the heater moves on from one end to the other end, இப்போ என்ன ஆகும்? நம்ம we are slowly moving the mobile or this heater to from one end to the other end. At the time, all these impurities are moved from one end to other end, I can say. So at the point of heating, the metal melts, and as the heater moves on from one end of the rod to the other end, pure metal crystallizes. இப்போ pure metal என்ன ஆயிரும்னா crystallize ஆயிரும், while the impurities pass on to the adjacent melted zone னு சொல்கிறோம். அப்போது அந்த molten regionலேயே அந்த impurities எல்லாம் present ஆயிருக்கும். That will move from left to right, or when you move across, all the impurities present in that particular impure metal will be swept from one end to the other end. Now we have to repeat the process several times so that you will get highly pure metal. So highly pure metal can be obtained by this method னு சொல்கிறோம். ஸோ இந்த மெத்தடில் வந்து நான் ஏற்கனவே சொன்ன மாதிரி we are purifying or we are refining some elements which are used as semiconductors. சரிங்களா? அது என்னென்னு உங்களுக்கு நம்ம படித்தாச்சு. இப்போது நெக்ஸ்ட் மெத்தட் ஆஃப் ரிஃபைனிங் வில் பி சே Mond's process. இந்த Mond's process அப்படிங்கிறது ஒரு வேப்பர் ஃபேஸ் மெத்தடுன்னு சொல்கிறோம். இந்த Mond's process and next one Van Arkel process. இந்த Mond's processல வந்து what we are doing is we are refining nickel. சரிங்களா? So nickel is purified by this method. இந்த இடத்துல நம்ம என்ன செய்கிறோம்? impure நிக்கலை ஆர் த crude நிக்கலை வந்து கார்பன் மோனாக்சைடு கூட we are heating to a temperature of around say 350 Kelvin. So when impure nickel or crude nickel is treated with carbon monoxide at about say 350 Kelvin, we get a complex called nickel tetracarbonate. ஒரு complex form ஆகுது. This complex is volatile in nature, which undergoes evaporation easily. So the first stage, impure nickel is treated with carbon monoxide at about 350 Kelvin to get nickel tetracarbonyl, a volatile complex. In the volatile complex என்ன பண்றோம்? Further when you heat it to about say 460 Kelvin, you will get pure nickel. And again carbon monoxide comes out, which can be reused னு சொல்றாங்க. So இந்த இடத்துல இந்த impurities எல்லாம் வந்து அங்கே இருக்கும். So we will get only pure metal at last. So impure nickel is converted into pure nickel by this method, which we call it as a Mond's process. சரிங்களா? அடுத்தது என்னன்னா say Van Arkel process. இந்த Van Arkel processல வந்து மெயினாக நம்ம வந்து we are purifying some metals such as titanium, zirconium, hafnium, silicon, etc. So these metals can be purified by Van Arkel process. Generally, this method is used for obtaining ultra pure metals. ரொம்ப ரொம்ப உங்களுக்கு வந்து 100% pure purity வேணும்னா you can go for this Van Arkel process. Here, say, let us consider with the titanium as example. இந்த இடத்துல டைட்டேனியம் வந்து நம்ம என்ன செய்கிறோம், we are treating it with iodine vapor. So in that, when titanium is treated with iodine vapor at a temperature of around say 523 or 550 Kelvin, நமக்கு என்ன கிடைக்கும்னா you will get a volatile compound which we call it as titanium tetraiodide. Again, this is volatile in nature. இப்போ இந்த டைட்டானியம் tetraiodide vapors வந்து எலக்ட்ரிக்கலாக டீகம்போஸ் பண்ணுறோம். ஸோ we are decomposing electrically using tungsten filament. So when we do so, pure titanium is obtained, iodine vapors are again passed out. So in this way we will get pure titanium from impure titanium. சரிங்களா? இதில் வந்து ஒரு drawback என்னன்னா, this is quite an expensive method. So only when we require metal with ultra high purity, so only when you want ultra pure metal, you have to go for this technique called Van Arkel process. Using this method, titanium, zirconium, hafnium, silicon can be purified னு சொல்கிறோம். இந்த இதில் both Mond's process as well as Van Arkel's process, these two are vapor phase மெத்தட்னு சொல்லியாச்சு. ஏன்னா அதில் வந்து நம்ம என்ன செய்கிறோம், அந்த volatile compoundே வந்து உங்களுக்கு vapor stateல தான் இருக்கும். அதை ஃபர்தராக நம்ம வந்து decompose பண்ணணும். When you decompose that, you will get pure metal. So in this way, we can explain the refining techniques. So let me summarize once again. The metal which is extracted from the ore is not 100% pure. சரிங்களா? So to get 100% pure metal, we need to remove the impurities present in those metals. And the impurities are of various types, and depending upon the nature of the impurities present and that of the metal, we have different refining techniques such as distillation, liquefaction, we have zone refining, electrolytic refining, Mond's process, and Van Arkel's process. Hope you have understood what I said. In case of any doubt, you please raise that in comment section. Thanks for watching.